Hello everyone. I am Vineet Kumar Sinha from ABES Engineering College, Ghaziabad. In today's video lecture series, we are discussing the subject Materials Engineering, and we are discussing Unit 5, that is non-destructive testing. And today's topic for the video is liquid penetrant testing. So, as per the syllabus, we'll covering the introduction to NDT, introduction to various non-destructive testings. What are the methods and how do we do that? And in the two testing methods, that is visual testing method and liquid penetrant testing method, could be discussed. So coming on to non-destructive testing, NDT, it is in short, it is called NDT. Non-destructive testing is the process of inspecting. You can inspect something, test or evaluate. What can we do on what? On materials, components, or any assemblies for discontinuities or difference in characteristics without destroying the serviceability of the part or system. So the important part is without destroying the serviceability of the part of the system, we can inspect or check or evaluate for any discontinuities or differences in characteristics on any materials, components, or assemblies. In other words, when the inspection or test is completed, the part can still be used. If it is good, the part can still be used. So it is called non-destructive test. In contrast to NDT, other tests are destructive. Other than the NDTs are destructive in nature and are therefore done on a limited number of samples. Lot sampling can be done only because the sampled item or the product would be damaged and would no longer be in use, rather than on the materials, components, or assemblies actually being put into service. So because NDT does not permanently alter the article being inspected, it is highly valuable technique that can save both money and time in product evaluation, troubleshooting, and research. If we have a quick look on this comparison between destructive and non-destructive testing, then for destructive testing, tested specimens get deformed or damaged during the testing process. Specimen get deformed or damaged. And in the non-destructive testing, the specimen test does not get damaged or during the testing. Similarly, destructive testing is done to identify the chemical and physical properties of the chemical and physical properties can be ascertained by the destructive tests or methods. Non-destructive testing is carried out to find defects in the material. Destructive test is extremely useful for design purposes. NDT is great for spotting early deterioration signs of working equipment. In destructive testing, item cannot be used for its intended purpose. The items can be used in normal operation after testing if it is found not to be defective. Similarly, destructive testing is more expensive and time consuming. But NDT is quick and easy even though certain testing equipment can be fairly expensive. Examples of destructive tests are bending test, tensile test, hardness test, corrosion test, compression test, and so on. Examples of non-destructive testings are ultrasonic test, radiographic test, vibration analysis, magnetic particle testing, and so on. So, in brief, what are the various common NDT test methods, non-destructive test methods? The six most frequently used test methods are material particle testing, penetrant testing, radiographic testing, ultrasonic testing, emission, eddy current testing, and visual testing. Each of these test methods will be described, followed by the other less often used test methods as per the syllabus, that is acoustic testing, X-ray diffraction. These two have been added as per the syllabus, and the rest are the common techniques like visual inspection, liquid penetrate, magnetic particle, ultrasonic, radiography, and eddy current testing. Coming on to the first one, that is visual testing. It is the most commonly used test method because most test methods require that the operator look at the surface of the part. Therefore, it is inherent in most of the other test methods also being a part of that. As the name implies, visual testing involves the visual observation of the surface and to evaluate the presence of any surface discontinuities. It may be direct viewing using the line of sight vision or may be enhanced with the use of optical instruments such as magnifying glasses, CCDs, charge coupled devices, or computer assisted viewing systems like remote viewing. Corrosion, misalignments of parts, physical damage, and cracks are some of the discontinuities that may be detected by visual examination. Tools used in visual inspections are to enhance the visibility, mirrors, magnifying glasses, microscopes, borescopes, endoscopes, flexible fibers, closed circuit televisions for remote viewing and computer enhanced systems. Applications of visual inspection. It is used to inspect whether there is a misalignment of parts in the equipment. Check for corrosion, erosion, cracks, and deformities, any deformities of machine components. Inspect the plant components for any leakage or abnormal operation, and also used to identify the defects in weldments. In these places, visual inspection can be helpful. But what are the limitations? We can we can readily say that it can identify only large discontinuities, limited to surface discontinuities. Skilled labors are required. Result depend on the eye resolution of the inspector, and it may cause eye fatigue to the inspector. Coming on to the next one, that is liquid penetrant testing or simply penetrant testing. So the basic principle of LPT is that when a very low viscosity, very means highly fluid liquid, it's called the penetrant, is applied to the surface of a part where the defects or gaps is to be checked. It will penetrate into fissures and voids open to the surface, and subsequently, after the developer being used, it can be found out. So we can see from these images the application of the penetrant. This red color penetrant is applied on the surface, and if any crack is there, it gets filled in the gap, and from the surface it's wiped out or cleaned. The cleaning is done. Then that one developer is applied of contrast color. Developer is applied. That is called developing. And after a certain time, and the liquid penetrant uh, would make the color change of the developer, and hence we can interpret what is the exact size of that void or fissure or anything, or whatever the gaps or cracks is there on the surface. So liquid penetrant testing can be applied to most of materials, including metallic and non-metallic objects. Metallic material include aluminium. It may be implemented on aluminium, magnesium, titanium, cast iron, stainless steel, powdered metal products, copper, brass, bronze, etc. Non-metallic materials include ceramics, plastics, molded rubber, composites, glass, etc. Penetrant testing can't be applied on a porous surface. This is the limitation of this because porous surface will absorb the penetrant. So, discussing general principle, which we already have discussed. First, we have to do clean and dry test object. So the crack filled with dirt is to be removed and ideally cleaned. Fully cleaned surface should be there. Apply penetrant and let it penetrate for some time. Apply of the application of the penetrant and then to uh, let it be for some time so that it can be penetrate to the cracks or fissures. Then intermediate cleaning of the surface would be done. Remove excess penetrant. Apply developer. Application of developer. Evaluate indications. What are indications? At what places the color of the developer gets changed. and post-clean test object, and the post-cleaning of the test object for any further use, because it is NDT, non-destructive testing, and the tested item can be used further. Characteristic of good penetrants: it should spread easily over the surface. It should be easily drawn into discontinuities by capillary action, should not be harmful to the inspector or the material being tested, should possess high indicating capability, should remain in fluidic state, highly fluid state, should possess less dwell time. Dwell time means that waiting time for penetration also and for developing also. It should not affect the physical and chemical properties of the testing material. It should be cohesive, adhesive, and relatively low in cost. The properties of a good developer: it should have good absorption characteristic, so the penetrant can be absorbed back. It should have a good contrast background. It should be able to uniformly cover the surface with a thin, smooth coating. It should be chemically inert with test material, provide a good contrast background for bright and clean indications, should be non-toxic and easy to remove after inspection. Interpretation of results can be done from this table. So if the casting porosity is the defect is on the surface, then spherical surface indications can be obtained. Dotted lines means casting cold shut. Straight continuous surface lines obtained means there would be crack in the surface. Rag line of variable width means hot tears. Multiple irregular lines show hot treat cracks. Interconnecting lines show thermal cracks. If lack of fusion will be there, then broken line of varying width will be obtained. And fatigue cracks, then a continuous line in parts can be obtained. So in this way, the interpretation of results can be done by, and it can be indicated what is the defect in the surface. Typical applications of liquid penetrant inspection, that is aerospace, automobiles, railways, tools and dies, and inspection on reactors and tanks. Advantages and limitation of liquid penetrant. Advantages are that it's simple and inexpensive, versatile and portable, application to ferrous, non-ferrous, non-magnetic, complex shape materials which are non-porous and of any dimensions it can be done, detects cracks, seams, lack of bonding, etc. The limitation of this liquid penetrant testing method is detect surface flaws only, not for inside or the uh, beyond the surface flaws. Non-porous surface material, it is only available for non-porous surface for material, and surface cleaning before and after inspection requires a lot of time, energy, and costing. Deformed surfaces and surface coatings prevent detection. If if the surfaces get deformed and surface coatings is there on the surface, then it will prevent detection through liquid penetrant testing. So this is all about in this video. In the next video, rest further NDT techniques would be discussed. Thank you.